Hi there, we're looking at simplifying expressions. Expressions are collections of algebraic terms, so 4a and 2b as you'll see there, and also maybe some number terms as well. And it's an expression if it's not equal to anything. So 4a minus 2a minus 2 plus 5 is an expression. It's got an algebraic term in 4a, it's got some number terms, but it's not equal to anything, so that makes it an expression. If it had an equals in it, it would be an equation, and we'll be looking at those in another video. So to just get us started, we need to understand what like terms are, and that's terms that are similar. So for example, in this one we've got a 4a. There are no other a terms. There aren't any 2a's or 5a's, so there's no other like terms to 4a. However, there's a minus 2 and a plus 5. Now they're both number terms, so they're like terms. So we've got minus 2 and plus 5, which are like terms. So I'll put them in the red boxes just to indicate that they're similar things. Because they're like terms, you notice I'm putting in equals because what I'm about to write will be the same as the left-hand side. It doesn't mean I'm turning it into an equation. So the 4a, there's no other like terms, so the 4a will stay as it is. But because we've got negative 2 and plus 5, so if you think about a number line, if we were to start on negative 2 and go up by 5, we go to negative 1, 0, 1, 2, 3. So we'd end up at 3, and that's why we're going to have plus 3 on the end of our simplified expression. If we move to the next one, we're looking for like terms again. Now there's a 2b, an a, a 1, a minus b, and a 3. So we've got a couple of terms that have got a b in them. You'll notice I'm including the sign, the operation in front of each of the terms, and that's quite important. We've also got a couple of number terms as well. So we've got plus 1 and plus 3, which means that for the 2b, well, I'm also taking away a b from it, so we're just left with b. The plus a, there's no other a term, so that stays. And then we've got plus 1 plus 3, which means our simplified version of that expression is b plus a plus 4. You could also write that as a plus b plus 4, or 4 plus a plus b. As long as they stay the same sign, then we're fine. For our next one, you'll see we've got some x's. The letter doesn't particularly matter, it doesn't change anything. So we've got 4x there, and we've also got a minus x there. And then in addition to that, we've got a plus 5 and a plus 4. So we can use those to simplify it. So an expression that's the same as that, but simplified, is 4x minus x, so that's going to be 3x. And if we've got plus 5 plus another 4 plus 9, and there's our simplified expression. Finally, we've got this one down here, so we've got 2a, and there is another a term, so we've got 2a plus a. There's no other b term, so we'll leave that minus 5b, but there is a plus 3 and a minus 2. So if I pull all that together, we've got 2a plus another a. We've got minus 5b, and no other b terms, so leave that there. We've got plus 3 minus 2, which will leave us with plus 1. So there we go. We've simplified 4 expressions there. Do use this method yourself of putting circles or squares around like terms, because that's quite an important part to remember. We've got one final problem at the bottom here, which is a more of a wordy problem. There are 2 packets of sweets and 3 loose sweets. Create an expression for the number of sweets. Well, we don't know how many are in the packet, so I'm just going to say a packet has n sweets in it. Now there are 2 of those packets, so there's 2n plus the 3 loose sweets, and there you go. There's an expression for the number of sweets. Hope that was useful. Now have a go at the little 3 questions below to see if you've understood the information. Thank you very much for your time.